Good morning to all of you. Let's see one of the important feature of Java, inheritance. This concept you are observing in your daily life also. Okay, let me start this concept with an example. Let us assume that uh, you is there. You is a student. Okay, you are having a father. Father. This person is having a grandfather. Grandfather. Okay, so assume that this grandfather has earned 20 acres of land during their time. 20 acres of land, and that 20 acres of land will be automatically given to whom? His children. His children. So this person, what he will do is he will get 20 acres of land, and with his own capability he can able to earn, let us assume that 10 acres of land, total 30 acres of land. Later what this person will do, assume that it's a kind of Sunil, assume Sunil, 30 acres of land, 30 acres. Now with the knowledge of Sunil, he can able to earn once again 20 acres of land. So now how many acres of land is there? 20 acres of land is there with Sunil. There with Sunil. Okay, fine. So now what happened here? Initially, there is a person. He has in 20 acres of land. He has in 20 acres of land, and before he died, he has handed over his 20 acres of land to his children. 20 acres of land to his children, and after that, this person will hand over. This person has earned 10 acres of land in addition to this 20 acres of land which was came from his father. So total 30 acres of land is there with Sunil father. Later, Sunil father will hand over this 30 acres of land to the Sunil, and then in addition to this 30 acres of land, he can able to like assume that he earned 20 acres of land. Total, how many acres of land is there with Sunil? 50 acres of land is there. Meaning that it's a kind of relationship. It's a kind of relationship. What kind of relationship it is? Parent-child relationship. Parent-child relationship, right? So with respect to Sunil, father is what? Father is a parent, and with respect to father, Sunil is a child. Sunil is a child. With respect to father, see, observe. With respect to this father, grandfather is a parent. With respect ఆస్తులు అంటాం కదమ్మా, ఆస్తులు ఏవైతే ఉన్నాయో పేరెంట్స్ కి అవన్నీ కూడా ఆటోమేటిక్ ఎవరికి వస్తాయి? దేర్ చిల్డ్రన్ కి వస్తాయి. ఇప్పుడు చిల్డ్రన్ 10 acres ఆఫ్ ల్యాండ్ ఎక్స్ట్రా సంపాదించారు. ఈ 10 acres ఆఫ్ ఎక్స్ట్రా ల్యాండ్ సంపాదించింది కెన్ ఇట్ విల్ బి గివెన్ టు గ్రాండ్ ఫాదర్? నో, ఇట్ కాంట్ పాసిబుల్. మనం సంపాదించుకుని మన దగ్గర ఉంటుంది, లేదా మన చిల్డ్రన్స్ కి ఇస్తాం కానీ మన పై వాళ్ళకి ఇవ్వమమ్మా. అవునా కదా? ఎస్. అలాగే ఇక్కడ పేరెంట్ ఫాదర్ అనే అతను 30 acres ఆఫ్ ల్యాండ్, 30 acres ఆఫ్ ల్యాండ్ ఎవరికి ఇచ్చారు? సునీల్కి ఇచ్చారు. అండ్ వాట్ ఎవర్ ద 20 acres ఆఫ్ ల్యాండ్ దట్ ఈస్ గెయిన్ బై Sunil, he cannot give to his father. Cannot give to his father. This is a general concept in inheritance, meaning that whatever the ఆస్తులు ఏవైతే సునీల్ గ్రాండ్ ఫాదర్ దగ్గర ఉన్నా అవన్నీ కూడా ఎవరికి ఇచ్చారు? ఇతనికి ఇచ్చారు, ఫాదర్కి ఇచ్చారు. ఇతని దగ్గర ఏవైతే ఆస్తులు ఉన్నా అవన్నీ కూడా సునీల్కి ఇచ్చారు. బట్ రివర్స్ ఈజ్ నాట్ పాసిబుల్. Reverse is not possible. Like, let us assume, ఇది అర్థం కాకపోతే మీకు I will take one more new example. Let us take in olden days there are TVs are there. Let us assume that this is a kind of TV. Okay, fine. So here this TV, what we can do with this TV, we can able to operate, we can able to on we can able to off, we can able to view all the channels or not. Yes. But later with help of all these features, we got big screen TVs. We got big screen TVs, right? Here, what they use, they are using uh, like monitors like CRTs. Nowadays, they are using LEDs. LEDs. And in olden days, internet is not supported, but here, internet is supported. Internet is supported. I mean, what I want to say here is, whatever the features that are there in olden TVs, those are all the features are here or not. On option is there, off option is there, view option is there, all are there in latest TVs also. But in latest TVs we'll have an internet facility, but in olden days it is not possible in reverse. This is the concept of inheritance, real time. Or else, let me take one more thing. Uh, there is a person. There is a person. This person having uh, two eyes, two eyes, one nose, two legs, two hands, or not? Yes, this is the person. Now, what are the what are the features are there for the person? Those features are having are applicable to student or not? Yes, those features are directly applicable to student. Yes, meaning that student is also having two eyes, student is also having one nose, student is also having two legs, student is also having two hands. But I mean, what I can say, these are all the features are applicable to student also. In addition to this, student having some extra properties, like student having some marks. Student can able to qualify in the exam. That's a kind of method. Am I right or not? Yes. I mean, what are the features that are there for the person? Those features are applicable to student. In addition to this, he can have extra features like marks and qualifying method. What a person can do? Person can do sleep. Similarly, this sleep method can be applicable to student or not? Yes, student also can sleep. This is where the concept of inheriting, meaning that student inherit the properties of person, but vice versa is not possible. Meaning that we can say every student is a person. Every student is a person, but every person need not be a student. Need not be a student, because person doesn't having any marks. Person doesn't qualify the exam. So this reverse is not possible. This is where we can see the concept of inheritance. Or else, let me take one more thing. There is a human. There is a human. Human having the properties, the same properties. He is having two eyes, uh, two legs, one nose, uh, two hands, etc. All these properties, right? If you take, if you classify this human, we may classify it as male, and we may classify it as female, right? Male is a person, male is a human. He is also having the properties of two eyes, two legs, one nose, and two hands. Female is also a human. She is also having two eyes, two legs, one nose, and two hands. But in addition to these existing human features, he may have extra features like bird. Okay. Have some extra features. Am I right or not? So with this, I can say that inheritance means we are going to acquire some properties from the previous one. Some properties from the previous one. Simply చెప్పాలంటే అమ్మా ఒక చిన్న పాయింట్ లో మీరున్నారు, యాజ్ యు ఆర్, రైట్? మీకున్న క్వాలిటీస్ ఎవరి నుంచి వస్తాయి? మీ పేరెంట్స్ నుంచి వస్తాయి. Parents, that's it. That itself like inheritance. Getting the properties from your parents to you is called an inheritance. Okay, coming to Java concept, we can say that, for example, let me create a person. Let me create a person. Uh, there is a class called person. So this person having what are there? This person can having uh, int number of eyes, int weight is also there, int number of legs, like this. All some properties are there. In addition to that, he can have some methods. Some, like a class is a collection of data members and methods, right? He can have some method, sleep method. He can able to sleep. He can able to sleep. Now there is one class. That class name is student. Student. Now what we can do? These are all the properties are available in the person. Those properties we need to get back to the class student. We need to get back to the student so that we can apply the concept of inheritance. Apply the concept of inheritance, right? So suppose that we have applied the concept of inheritance for the student class also. Then what will happen? All these properties will automatically will get into this class. Will automatically get into the class. In addition to that, if you want to add new features, you can add. Like for example, I want to add marks. I want to add one more method like qualify method. Qualify method, right? Yes. Meaning that, observe here, what are the features that are defined here through the concept of inheritance, I can able to get to this student. I can able to get to the student. But what are the features that I have defined to the student, those are all not get back to the previous class. Not get back to the previous class. I hope you understood. Okay, now let me define the definition of inheritance. With that concept, I can able to define inheritance. So inheritance means it is a process of getting the features from one class to another class is called as inheritance. Simply I will write process of getting features from one class to another class is called as inheritance. Features means I already said data members and methods. Okay, fine. Like see, there is a class called what is this? Person class, and there is a class called student class, and the student class also having some data members and methods. Similarly, this person is also having data members and methods. If you are applying some kind of relationship like inheritance, then automatically the features of this person class will comes to this class. Data members and methods. But vice versa is not possible. అంతే కదమ్మా, మనం సంపాదించిన ఆస్తులు మనకు ఉంటాయి కానీ మన పేరెంట్స్ వాళ్ళకి వెళ్ళవు. బట్ మనం సంపాదించిన ఆస్తులు మన పిల్ల వాళ్ళకి వెళ్ళచ్చు. Yes, that concept is related to inheritance. Yes. Okay, fine. Here this is a kind of person is a class which is giving the features, then we can call it as parent, right? So this class I will call it as parent class, or we can call it as super class, or I can call it as base class. This class we can simply call it as child class or subclass, or we can call it as a derived class. Derived class. Meaning that, see, what do you mean by parent class? The class which is giving features to some other class. The class which is giving features to some other class is called as a parent class. What do you mean by child class? The class which is taking features from some other class is called as child class. This is parent class is giving. Okay. So here this inheritance concept we can also call it as uh, reusability or derivation, or we can call it as also subclassing, or we can also call it as extendable classes. We can call with any name. Okay, fine. See here the important thing. Once I have applied the concept of inheritance, whatever the data members and methods are there, those are all available in student class. Those are all available in students class. But here, how they available is they are available logically. I mean, these data members and methods are available logically in the child class, but it won't occupy any amount of memory space. Okay, simply I can say that derived class or child class or subclass means it contains what? It contains features of base class. Base class means parent class, and the features of its own class. Features of its own class. So now tell me, which is having more features? Obviously, derived class is having more features, compared to base class, because this derived class contains the features of parent class as well as its own features. So obviously the derived class is having more features. Sir, when we go for the concept of inheritance, meaning that what is the need of, I mean, what is the need of inheritance? Wherever you want to reuse the components, wherever you want to reuse something, then you'll go for the concept of inheritance concept. So if you go for reusability, what are the advantages? We'll get lot of advantages, right? So once we reuse a code, see here, uh, I have written like data members and methods. As I written anything here in the student class? No. Meaning that we can reuse something. We can reuse. So that I no need to rewrite anything again and again. So once I use the concept of inheritance, obviously application development time is less. కోడ్ మళ్ళా మళ్ళీ రాయకుండా ఉంటే ఏమంటున్నామో టైం డెవలప్మెంట్ టైం తగ్గుతుందా తగ్గదా? ఎస్. And also see here, if I write these data members and methods physically without applying the concept of inheritance concept, then what will happen? Memory will be increased or not? In the place of this one, memory will be increased. So if you use the concept of inheritance, obviously memory space is also taking less. What about execution time? Execution time will also reduce. Is also less. And as application development time is less, memory space is less, what about the performance? Performance will be improved. And can we use code reusability or not? Yes, we can able to code reusability. And in the starting of the classes, I have said one principle, wara, write once, and reuse it, right? Once, and it can implement the feature of this vara also. So these are the advantages of applying the concept of inheritance. Okay. If you see, there are various types of inheritance is there. Various types of inheritance are there. Like, hmm, first one, single inheritance. Single inheritance, meaning that in single inheritance, there exists only one base class. There exists only one base class, and there exists only one derived class. This kind of inheritance we'll call it as a single inheritance. This is base class and this is a derived class. That is, this is C1, C2. And how the features are moving? Features are moving from C1 to C2, but not from C2 to C1 in single inheritance. Meaning that in single inheritance, there exists only one base class, exactly one base class and one derived class. See, child class also called as derived class and parent class is also called as base class. I will use the technical terms. Okay. And there is another type of inheritance that is multi-level inheritance. Multi-level building. I mean, multi-level inheritance means multi-level building antam kada. Multi-level building means storied building, like fourth floor, fifth floor, one by one, top to top untayi kada. Vatlanniti multi-levels anochu. So multi-level inheritance means, see, I will take example. This is a class. So this class I will call it as base class. Call it as base class. And this is a class, something like, let us assume that C4. This class I'm calling it as derived class. In between, we'll have n number of floors. I mean that we'll have n number of classes. We won't bother about how many number of classes are there. Let us assume that there are two classes are there in between. These classes will call it as intermediate base classes. Meaning that in this inheritance, in this multi-level inheritance, there exists one base class and one derived class, and multiple intermediate base classes. Multiple intermediate base classes. Okay, fine. So see, observe here, with respect to C2, C1 is parent. C1 is parent. With respect to C1, C2 is what? Child. With respect to C3, C2 is what? Parent. With respect to C2, C3 is child. With respect to C4, C3 is parent. With respect to C4 is child. With respect to some other, C4 is what? Always something, child. So I hope you understood what do you mean by intermediate base classes. So intermediate base classes means sometimes they will act as a parent and sometimes they will act as child. So the classes which are acting as sometimes parent and sometimes child, then we can call those classes as intermediate base classes. Intermediate. So how the features are transmitting here from C1 to C2, C2 to C3, C3 to C4. Like this, the features are traversing, but vice versa is not possible. It's not only from here to here, it is also not from here to here also. Okay. There is another type of inheritance. There are 5 types of inheritance are there actually. Hierarchical inheritance. Hierarchical inheritance. So in this type of inheritance, there exists a single base class, and will have multiple derived classes. Will have multiple These are all, we call it as derived classes. Multiple derived classes. Then this kind of inheritance we call it as hierarchical inheritance. Single base class and multiple derived classes. So what is the flow of flowing the properties? It can flow from C1 to C2, C1 to C3, or C1 to C4, C1 to C1 to C5, and so on, C1 to Cn. But reverse is not possible. Reverse is not possible. And also from C2 to C3 is flowing? No. C2 to C3 or some other derived in between derived classes, there is no possibility of flowing the information. Okay. There is one more type of inheritance, multiple inheritance. This is I have already explained at the starting of the semester. So is Java is supporting multiple inheritance? Obviously no, but yes, it can support it through the concept of interfaces అని చెప్పి నేను ఫస్ట్ లో చెప్పాను. Yes, what do you mean multiple? Sorry, it is multi-level and this is multiple inheritance. In multiple inheritance, what is happening? There are multiple base classes. There are multiple base classes and there exists only one something like that is in the C0. One derived class. These are all base classes. This is not possible in Java, but it is possible through the concept of interfaces. You may ask the question, why it is not possible? See guys, I will explain with an example. Let me take first here. What is the definition of multiple inheritance? There are multiple base classes will have only single derived class. In C++, is C++ supports multiple inheritance or not? Yes, C++ supports multiple inheritance. Okay, fine. Let me take with an example. See, there exists some class. There exists some class A. Some class A, and there exists some class B. Some class B. Here, there is a variable int A. Int A equal to 2, and there is a variable int A equal to 3. Int A equal to 3. And I mean, so the class name is A, the class name is B, and I am trying to inherit into the class C class. So then what I will do? I'll go for taking class C. Assume some keywords I will use class C. So in this class C, what I will do? I am trying to print system.out.print of A. Now what will happen? The JVM compiler will get an ambiguity. Why it will get an ambiguity? Because this is a derived class. This is a derived class. In this derived class, what are the features available? The features of both class A and class B features are available. Class A and class B features are available. I mean, indirectly, A equal to 2 is available, A equal to 3 is available logically in class C. Then now compiler will get an ambiguity whether I want to print this 2 or this 3. This 2 or this 3. So the compiler will get an ambiguity. So it is providing a compile time error. It will provide a compile time error. So that is the reason multiple inheritance are not supported through the concept of classes, but it can support the concept of interfaces. Okay, fine. There is one more type of inheritance is there, that is hybrid inheritance. Hybrid means a combination of all. So in hybrid inheritance, it can be a combination of all available inheritances. All available inheritances. If this combination contains any one of the if this combination includes multiple inheritance, then it is not support the concept of Java. Okay. For example, let me write like this: C1 is a class, and C2 is a derived class. Now from C2, I am getting C3 and C4. This is what from here to here, it is a kind of single inheritance in the single base class and single derived class. And what about this part? This part is have you observed anywhere? This is hierarchical inheritance. Very good. Hierarchical inheritance. So this structure is a combination of not combination of all available, some combination of any available inheritance. Then we can call this as hybrid inheritance. Now let me take one more example. There is a class C1 and derived class C2 and derived class C3. This is what hierarchical inheritance. Now from C2 and C3, I am going to derive the class C4. Now what happened here? It is like it contains, this part contains multiple inheritance. Multiple inheritance, right? As there is a concept of multiple inheritance in a particular structure, it is not supported through the concept of classes. So this entire structure cannot implement to the concept of classes. I mean, it is invalid by classes, but we can do it through the concept of interfaces. Interface and ఏంటమ్మా? I have defined in the starting of interface is also an user defined data type. Class is also an user defined data type. That is what I said in the starting of the classes. Okay. So okay. So these are the various types of inheritance, like single inheritance, multi-level, hierarchical, multiple inheritance, and hybrid inheritance. Hybrid. Okay, fine. Up to here we have discussed the what is inheritance and the types of inheritance. Now let's see how to implement this inheritance concept. For that we have to check, we have to see the concept first, syntax, right? So to implement the inheritance concept, we have to use the keyword extends keyword. Like see, the syntax is the syntax for derived class. Like for example, see, there is a structure like C1, which is base class. Base class means it's a normal class. It won't have any extra thing. But for example, if I want to get this base class features to C2, then I have to apply the concept of inheritance. So this class I will call it as derived class. So with respect to derived class, I am writing the syntax. So how to inherit these base class features? First, you have to write the derived class name. Class, that class name, derived class name. And to make the Java compiler to understood, I want to implement inheritance concept. We have to use the keyword extends keyword, followed by from which class I want to inherit. From which class you want to inherit, that I'm going to write as a class name, something like this is 1, this is 2. And you are going to perform some kind of variable declaration, method declaration. This is the structure. Okay. Like for example, for this I want to write. Then what I will write? Class. What is the class name of derived class? C2. What is the keyword? I want to use extends keyword. Which class I want to extend? C1. Then I will write so on. Okay. Here C2 or let me take this one. Class name 1. Class name 1 defines what? Derived class name. And class name 2 defines base class name. Extends, it's a predefined keyword in Java, which is to tell the compiler that I want to implement the concept of inheritance. Meaning that to inherit the features from base class to derived class, we'll use the keyword extends keyword. Okay, fine. Now, tell me, see, with this I can write this one. See, go for writing this one, right? What? How can I write? Class C2. Try and run also more. Class C2 extends C1. Can I write it or not? Yes, it is possible. How can I write multi-level inheritance? First, see, first base class I will write, right? Base class C1. That's it. Next, I will go for multi-level inheritance. So in multi-level inheritance, first I will write base class C1. Class C1. I will have some logic. Okay. Next, I want to implement C2. C2. So for that, I will take class C2. C2 is performing what? It is taking features from C1. So I have to write extends keyword. From which class I want to derive? C1. So I have written like C1. Okay. Next, I want to implement class C3. Then what I will do? Class C3. It contains some features. Right now, the C3 is extending the features from which class? C2. So I will write like extends C2. Now again C4. So I will go for writing like class C4 extends C3. Okay, fine. So this way you can implement multi-level inheritance. Okay, if you draw same diagram for this, you will get the same structure also. Okay. Similarly, what about hierarchical inheritance? There exists a single class C1. This single class C1, you are going to extend every time. Class C2 extends C1. That's it. Next, for example, next class C3 extends C1. Class Cn extends C1. What is the meaning of this one? For class C2, I am extending the features of C1, meaning that these properties are all applicable to C2 also. Like this, you are going to implement. What about multiple inheritance? If you try to like this, if you try to write, this is CO, right? If I try to write class CO extends, like for example, assume that there are only two classes. From two class, you have inheritance means it is a multiple inheritance, right? I will write like C1 comma C2. Then what will happen? Immediately, compiler will produce an error. Why it is producing an error? Because of ambiguity. Why you are getting ambiguity? It is going to get the features from both C1 and C2. At sometimes there is a chance of getting both features having same names, and the compiler will get an ambiguity whether I want to take this A or this A. So that is the reason this syntax is not allowed in Java. This syntax is not allowed means multiple inheritance is not allowed in Java. Go for coming to the implementation of hybrid inheritance. In hybrid inheritance, I will write only one more. This one. Let me take first class C1. Some features I have added. Then I want to go for C2 implementation. So for C2 implementation, I will take class C2 extends C1. Some features are there. Next, if I want to implement the C2 features to C3, then I will write class C3 extends which? C2. Next, C4 means class C4 extends again C2 only. Like this, we can implement various types of inheritance in Java. Okay, na fine. So extend is a keyword which is meant for to implement the concept of inheritance. Okay, fine. Let us see one simple program through the concept of inheritance. I will write like C inheritance. Control yes. Sorry, I need to save. Now I want to save respect to this class name. Inheritance dot Java. Now what my requirement is, I want to implement the concept of inheritance. Okay, fine. So let me first explain what I'm going to do. Example, class C1, class C2. What I'm going to do? I'm going to extend the class C1. So here what I'm going to do is I'm going to take int some a equal to 5. Int b equal to 6. Equal 6, and then I will go for defining some show method, right? So if you are not writing anything, you should mention with the void. I'm trying to display some value. System dot out dot println of a and b value from base class, right? This is base class. Base class. So I'm going to make plus a I'm just making append with hyphen. Okay. Plus b. Okay, fine. There is no problem with this. Now, guys, please make understood here. As I have mentioned it as extends class. I mentioned it as extends class, meaning that these features are by default available here. I'm just making a comment. That's it. Ivanni kuda logically available. Logically available. Because we have inherited the concept, we have inherited from C1, meaning that int a equal to 5, b equal to 6, some all these are available here. Now what I will do is I'm going to make some int c equal to some value 10, equal some value 10. Here also I will declare some method, some display method. Display method I have taken, and I am trying to print. System dot out dot println of plus a okay, anyway, c value from derived class plus c from derived class plus c I have defined, right? So as this is with respect to same class, I can able to display directly. I can able directly display. See, if I want to, guys, if these are available logically here, can I able to print these values or not? Yes, I can able to print these values also. If you want, you can print outside, or I want to make it inside the method. A and B values from derived class. Why I am making it as from derived class? Because these previous class features are logically available in the same class in the C2. Yes, once they are available in C2, then I can able to print it directly or not. Yes, I can able to print it directly. Yes, I can print. Okay, I have printed. But if you try to print, the value C in this class, you will get an error. Okay, fine. Now I will create an object for C1 class. Main method parts execution. First, I will go for creating an object of C1. C1. Right? So I didn't mention. I didn't use it here capital letters. It is compulsory how to use as. It is not compulsory, but if you make it as practice, it will be good for you. C1. Something like C equal to new C1. New C1. Right? Once I made like this, what happened here? Here you can understood that I have instantiated the class C1, meaning that disabled I can able to access. Yes. So now if I try to print, anyway, I will directly write. I will directly call the method c dot show method. C dot show method. If I try to call, what will you will get the answer, right? See, you will get the answer from base class. You will get the A and B values. Java C space inheritance dot Java. Yes, successfully compiled. Java space C inheritance. Now we'll get A and B. See, main method starts executing. A and B values from base class is 5, 6. 5, 6. Yes. Now, if I want to call C2 objects, C2 class data members, I'll go for defining C2 B equal to new C2. New C2. Now I will write like D dot display. D dot display. Now, what is the answer you will get? First, you will get the answer as a value from base class. As I'm okay. Anyway, okay, no problem. I'll make it more look. Base class. This is derived class. Okay, fine. From base class, I can able to display. From derived class, if I am trying to call display method, what will happen here? It will print A and B value from derived class is A and B. From C, it is C. Meaning that with this calling, I can confirm that A and B are available in C2 also. Right? From base class, I have called the A and B 5, 6. A and B from derived class 5, 6. You got same answer. C value from D 10. You got the answer. Okay, fine. Now, can I call with respect to this object? Can I call show method or not? Just observe. Can I call show method or not? Yes. With respect to D is an object of which class? C2. Go to C2. Show method is really we have written here show method? No. But it is logically available. Why? Because it is implemented from C1 and it will go for C1 and it will check for show method. Yes, C1 is there. Then it will print that value also. C value is from DC is 10 and A and B value from base class also 5, 6. Again it is called. So now what I will do is I'll go for making one more again I'm making as from base class. From base class, if I am calling means I can call with respect to C dot. If I try to perform display method, to perform display method, what will happen? First it will go to C object is where, which location? C1. So go for C1 class and it will try for checking display method. Is there any display method? No display method. So you will get display method is not available. You will get the answer. See what you got? Cannot find the symbol display method. So with this statement I can say that reverse means C2 features are not available in C1, but C1 features are available in C2. So this is an error. Here the important point I want to highlight is, see, uh, when you apply the concept of inheritance, uh, if you create an object for which class, so that you can able to get the features of all classes. See, if I able to create object of derived class, I can able to get the base class features or not. But if I create an object of base class, I cannot able to get the features of derived class. So the important point really, what I want to conclude is, whenever we are going to develop any kind of inheritance application, it is always recommended to use. It is always recommended to create object of derived class. Object of derived class. I mean, object of derived class means object of bottommost class. So that in this bottommost class, all the features are available directly. So that you don't need to create n number of objects for each and every class. Once you create an object for bottommost derived class, automatically this class contains all the features. Okay, fine. See, whenever you create an object for the bottommost derived class, first memory will be created for which location? See, if here assuming that I'm making comment from here to here. I'm making comment here to here. Even though I'm making comments, see, what is this statement? I'm creating an object for C2. Once I create an object for C2, automatically memory will be instantiated for C2. But to make instantiation for memory C2, first it is going to extend from C1. So first it will create memory for C1. If this class is also extend some memory, then first it will create memory for the previous one. So meaning that whenever you create an object for bottommost derived classes, first memory will be instantiated for topmost class. I mean, first it is going to create for first class, then it is going to instantiate for second class, then later on the last it is going to memory instantiate for bottommost class. Fine. So in the bottommost class, memory will be created. But what about the features? All the features are available only logically. Okay. What about execution? Okay. See here, my point is memory is instantiated from top to bottom. What about execution? Execution is from bottom to top. See, if I am calling d dot show, first what it is going to do? It is going to go for C2 class. In C2 class, first it will check for show method. Is there any show method? No. They will check for, is there any inheritance concept applied? Yes. Then it will go for checking the previous class show method. Guys, if you want to write your own show method also here. See, if I write like void show. System dot out dot println of Here also show method is there. Here show method. I'm just what I'm doing is overriding. This concept overriding uh, base class uh, show method in derived class so you have to understood one here. Whenever I call d dot show, d is an object related to c2, so it'll go for c2 class. There first it'll check for is there any show method or not. Yes, there is a show method. Then it is going to print this one. If this show method is not there, this show method is not there, then it'll go for checking the parent class, meaning that how the execution flow. Execution is flowing from bottom to top. Now check. If you want, I will execute. See what happened. Main method starts executing derived class a and b value from derived class, overriding bc show method in dc. What is 10 here? C value from dc 10. What I did, d dot show d dot show. If I call like d dot show, here I have mentioned right c value. That c value is going to get right overriding from C method. If there is no overriding here, then I will go for checking the previous one. So that is the meaning of this one. So memory instantiated from top to bottom, but program execution from bottom to top. Okay. Here, see here there are some features. Are there. All these features I am going to inherit it to the class C2 directly. But I don't want to inherit all the features. Meaning that, for example, there is an some variable called age value whose age is 10. I don't want to inherit this age to the my child classes. Then what I will do? I can go for defining it as private. Meaning that if you don't want to provide some of the features to the base derived classes, then I will go for defining it as private. Once I made it as private, automatically that feature is not invoked here. See, let me show. If I make here as private, what is the meaning of this one? This is the variable I want to use within the class only. Even though I implemented using the concept of extends keyword, that feature is not inherited to here. Now what you will get? You will get an error. Why? Because B is undeclared. What happened? B has private access in so. I mean, if you don't want to give some of the features from base class to the derived classes, then I will go for making it as a private. Okay, this is for today's class. Okay, we'll continue in the next class.